Hello, everybody. Welcome to the Togo.io Partner Webinar Series 2025. I've been very excited about this webinar for quite some time. We have Device Solutions with us. I'll introduce the speaker to you in a minute, but today's topic is future-proofing IoT, navigating the rise and fall of cellular technologies. We're going to have a lot of great information on this webinar, but I want to take care of a little bit of housekeeping first. You'll notice there's a chat. In that chat, feel free to ask questions at any time. We'll try to answer them in real time, or we'll get to them at the end. But we'll navigate that as we go. But feel free. I'm from Raleigh, North Carolina. I have Chris Lamb with me. We've been partners for almost 10 years. We've done hundreds of projects together. So we know each other very well. We're both from Raleigh, North Carolina. So go ahead and post where you're from. But with that, I am David Hall, as I said, Customer Success Manager, and I have Chris Lamb, the CEO of Device Solutions, which I'm very excited, Chris, about this webinar. Thank you very much for joining.
Yeah, thank you, David, and thank you, everybody, for joining. Excited to do this. So, as David said, I'm Chris Lamb. I'm the co-founder and CEO here at Device Solutions. We'll talk a little bit more about Device Solutions in one of these slides. We worked a long time with David and his team. There's a lot here to go over, and hopefully you all will find it very helpful.
Thank you, Chris. I see Jim from RTP, a local person, has joined. Thank you for joining, Jim. Appreciate it. So we already went through the welcome, and some of these topics, obviously, we're going to expand on them. But, challenges and types of connectivities, there's lots of options out there, right? And it's really hard to figure out and navigate what's the right one for you, right? So how to choose the right connections, and it's extremely important. I think we can all agree with that. And then how do we prepare for changes, right? That's really important as well. What I like to say about Togo is it's all about customization, right? And really, when you're thinking about Togo, you can start simple, but you can really scale without having to change platforms, and you can build it all yourself, right? So there's a lot to go into from that aspect. And then also something that's very important is the interoperability with Togo, right? What if something happens? And I'll get into that when I get to my section of the webinar of how easy it is to interchange certain things within the Togo ecosystem, right? To just really keep you flowing in a very fluent manner, right? And then, of course, we'll save a little bit of time at the end for Q&A. But as I said, at any time, feel free to post your questions, and we'll get to them, try to get to them in real time, or we'll get to them at the end. But as I said at the top of this webinar, I'm very excited about this webinar. This is going to be a good one, guys. This is probably my top one for the year. No kidding. I do a lot of webinars. So with that, I'm going to pass it over to Chris, where he's going to talk a little bit about Device Solutions and some of the other topics that I spoke about in the agenda. So Chris, the floor is yours.
Yeah, thank you, David. And I think you're only saying that because it's the beginning of the year. We still have room to improve. Yeah. So a little bit about Device Solutions to get started. So we started Device Solutions in 2023 when we left Sony Ericsson during the transition of that joint venture and the dot-com bust and lots of other things going on. So 22 years in operation, many hundreds of projects and customers around the world, quite literally. We've grown over the last years to a 40-person team or a little more, and we're entirely focused on wireless engineering, embedded hardware, and firmware. So the stuff inside the box, I like to say. And we have great partners like Togo for the stuff outside of the box. Both the back-end and web stuff, connectivity for cellular things, as well as mechanical. So a few pictures of the team there. Hopefully we don't look too scary and look like a bunch of pretty serious, focused engineers. I think we've all seen over the last few years how dynamic the cellular world is, and I really want to spend some time talking about that history because it provides some insight into what drives that market, how we got where we are, and what's likely to keep happening. No matter how good 4G is, the next one is always coming. So let's revisit some history and sort of emphasize some of those points. 1G, also known as AMPS here in the U.S., analog mobile phone system, and NMT was one of the prevailing ones in Europe. Those rapidly gave way to much more efficient digital systems, DAMPs, and CDMA, and GSM around the world, various competing standards in those days, which made it extremely interesting in some ways. These digital standards made handheld devices practical, and some of you may remember some of those early flip phones and things like that. Very basic displays, limited applications, and typically no cameras. Those gradually evolved into 3G devices with enough data connectivity to support things like cameras. At that point, the DAMP standards died off. GSM became HSPA, UMTS type standards. The CDMA, Qualcomm world evolved into EVDO for their 3G data solution. And at this point, the things like applications became a lot more common, and things like cameras became a lot more common. So people used to ask us occasionally, where or why would I want a camera in my phone? And I like to say, I think that question is pretty well answered at this point in time. That's when we really all started having, internet in our pocket, being able to carry things around, really starting to be able to get data and email everywhere, and see this the benefits of a portable, battery-powered, always connected device. Over the last few years, 4G is fully rolled out. In 2022, February 22 officially, AT&T, for example, turned off their 3G network completely. 3G is available, 2G is available in the rest of the world, and that's an important consideration that in some markets you may need those for fallback. But at the same time, 3G, 4Gs continue to evolve to offer some more efficient IoT protocols, LTE, category M1, M2, narrowband IoT. Starting around 2016, those really became available, and they're widely deployed in many parts of the world, but you may still need fallback options. And in some places, that may well be 2G, not in the US, but perhaps some places in Asia, Europe, Africa, where that's necessary. And most of you probably have 5G supported devices. If not, your next one will definitely support 5G. And increasingly, that's rolling out more and more for IoT applications. It's a little slow due to the price of the modules and the complexity of the antennas, but we'll talk about that more. The important thing is that this march towards increased performance and complexity is going to continue. The driving factors for that are that the cellular frequencies and the infrastructure are really expensive. I was on the AT&T technical alignment meeting earlier this week, and again, the network and the spectrum that they've had to buy at auction is their most valuable and most expensive assets. So they're always looking to monetize that effectively. So the efficient use of spectrum is critical. How can we support more users, more applications, provide more data, make it more sticky? Yes, maybe some people or some applications are satisfied with 4G, for example, but everybody's going to eventually upgrade, right? Those that upgrade, the carriers that upgrade, that force you to upgrade, will be able to offer more data more efficiently at a more competitive price. So if one carrier chose not to get on the 5G bandwagon, they just wouldn't be able to compete commercially, and they wouldn't be able to support the number of users, the number of bits per hertz. So that's what's going to continue to drive this evolution. Spectrum efficiency, network capacity. So there's just no way to stop that, and that's really where the carriers are focused. So that's that kind of efficiency is very important to remember. So, before we dive into cellular too much, there's a lot of different kinds of connectivity. Each one has some interesting pros and cons, and I don't think I will go through all of those here on the webinar today, but want to hit a few highlights. Right, cellular is great. It's pretty ubiquitous here, at least in reasonably populated areas. But the far west, many parts of places like the Australian outback, and of course the oceans, are not covered. Where you do have coverage, you have a range of options, but that can be complicated because it may not be the same bands or the technologies everywhere that you want to cover. You may have to have complicated relationships with carriers, and a monthly subscription is required. And this is often fairly complicated even today with the world of eSIMs and profiles that can be updated and things like that. There's still a fair amount of overhead and headache making sure that all your devices are securely provisioned, and secure is an important part of that. So there's a lot of complexity and cost to cellular. The modules are neither as cheap as the other solutions or small, and while Cat M1 and narrowband are very power efficient, they can still be relative high power for some applications such as meter reading or something may still be challenging. Satellite connectivity is really evolving very rapidly. SpaceX, of course, gets the headlines right now, but in 2022 or so, when I was looking at this, there were, I think, over 20 startups in the satellite IoT space. Some of those have been acquired. I think Swarm was acquired by SpaceX a number of years ago. Plus, SpaceX is launching LTE connectivity. Others like Mariota out of Australia are still out there offering various radio combinations. And the cellular providers are increasingly supporting the cellular module providers, I should say, are increasingly providing options to connect to what they call non-terrestrial networks from the same module, since they support many of the similar frequencies and can sort of adapt their radios quickly to do this. But just like cellular, you're going to require a subscription. Your antennas are probably going to be more difficult and complex to integrate. The cost of the connectivity is going to be higher, and often the latency and things like that will be problematic. LoRaWAN is a technology that's been around for quite a while. We've done several LoRaWAN devices and even more custom devices with LoRa as a fundamental link layer, you could say, physical layer interface. It's a very long-range protocol relative to the power, but long range and low bit rate and low power should be there. So you can have both public and private network options. So even if there's not a public network for you to subscribe to, it's not hard to use either Helium to deploy your own network or deploy, a fully custom network. So that can often be an option, but does come with that complexity of figuring out, what is where, how do you want to do it, and does it support your needs, which we'll dive into a little later. Wi-Fi seems great. It seems to be everywhere you might need to be. You can have Wi-Fi all over a hotel, all over a campus like NC State here in Raleigh, or an airport. Power consumption is, lower than cellular perhaps on average, depending upon how you're using it. If you're always listening, it can be higher than a lot of the cellular protocols, so that may be a problem. It has limited roaming. If you're connected at Raleigh-Durham Airport, it doesn't mean you can connect anywhere else. It has no mobility, and there are often a lot of restrictions to connecting. So somewhere like NC State's campus allows you on the guest network quite easily, but every time you connect or reconnect, which might be several times a day, depending upon what's going on, you have to check a box to accept terms. This can be a little complicated to program into your device if it's a kind of a headless IoT device. And even if you do program it, those kinds of things change pretty often. So you have to have something that's very flexible to do that. Additionally, not all commercial environments or industrial environments will allow you on their network. So there will be a lot of effort to maintain that connection as networks are optimized, new hardware is rolled out, and passwords are rotated. We do a lot of projects with proprietary RF, as I said, often based on a LoRa radio, but not always. This allows you to really optimize it for power, range, and cost, especially if it's relatively short range, hundreds of yards or meters. But it often requires a custom hardware, custom software stack, ongoing maintenance and updates. And there's always a risk of vendor lock-in, right? If I'm using the LoRa radio, nobody can interoperate with me if they're not using that. And if you have a problem with supply chain or otherwise, you may have a hard time getting the chips you need to build this. And in the future, what's your roadmap for maybe more bits farther? You may have to do more of a redesign than if you are on a standardized technology that has a consistent roadmap. And I just want to mention, LPWA is a term that's often thrown around. It's sort of an umbrella term that covers a lot of these very low power technologies, whether they're cellular, Cat M1, LoRaWAN, or Sigfox. But these are really all the different radios can be lumped here for long battery life and infrequent communications, whether that's meter reading, telemetry, even things like asset tracking, things like that, often use some form of LPWA but really varies, very wide range of technology. So hard to kind of talk about that systematically and cover all of those. So this is a little bit of a rubric for thinking about how you might choose what connectivity to use. You could go through these in many different orders. Clearly, if you can't afford a cellular subscription or module, cost might be the first place to start. But I thought maybe we should start with geography, right? Is the signal you want to use there? So whether you're using cellular, Wi-Fi, LoRaWAN public, or you think about Sidewalk for Amazon, those are all pretty good options if you're in a pretty well-populated area. But as you get more remote and rural, you have to consider other options, whether that's a private LoRaWAN network, a satellite non-terrestrial network, or some sort of proprietary network that you roll out. So what is where you need to be? Do you have a way to access it? If you're doing cellular, you might consider things like you use a worldwide module, to use a module that's specific to a region or a carrier. How do you hedge your bets and lower your costs there? Once you've identified, hey, these are the network options that are physically present, can I access them? So yes, you have Wi-Fi at NC State, but as I said, it may be hard to access. Yes, you may have Wi-Fi at an office building or an industrial facility, but getting on and staying on that network may be hard. We've had many customers that we've recommended to, and many who've learned the hard way that industrial Wi-Fi turns out to be very hard. Working with every single customer to figure out their IT requirements, to figure out how you get certified to be on the network, and then maintaining that connectivity, whether it's their Wi-Fi going down, whether it's maintenance or passwords just being rotated periodically. They've found that this is often so problematic that they'd rather include more expensive cellular connectivity in their devices. So once you've found, what networks are available, or at least options in my geography, how do I get on them? Can I get on those networks? What kind of bandwidth and latency do you need? If you're willing to tolerate a little bit of latency, especially on the downlink, to wake up the device, a cellular Cat M1 device that sleeps most of the time, such as in a water meter, that can be very efficient. That can also be a good use case for LoRaWAN, where again, seconds are not critical, even maybe minutes. But if you need, more bandwidth, and maybe you start looking at LTE category M, more frequent wake ups, or even some satellite, depending upon where you are. Satellite's also very good for the lowest bandwidth applications. And this is again another place where LoRaWAN can play. Obviously, none of these sort of medium and low bandwidth are really going to send you very many pictures or audio and video very well, so you may be stuck using something like Cat 1 or RedCap there for 5G solutions, or Wi-Fi as well. Once you know sort of what meets your needs, do they meet your power? So if you have a very long battery life, again, meter reading, these kinds of applications, you may be looking at optimized Cat M1, narrowband, LoRaWAN. If you have more frequent charging, shorter battery life options, then maybe we can do cellular, Wi-Fi, and satellite. Those will be some of the trade-offs there. Of course, there are similar trade-offs for cost. Cellular and satellite are going to tend to be the most expensive, especially as you go higher and higher in bandwidth. I think it's always important to remember that the more bits per second you send, the farther you have to send those bits, the lower latency you have to send those, the more power it's going to consume, probably the more it's going to cost. So it's the traditional kind of three-legged stool. More bits over more distance, is almost always going to cost you more power and more dollars. So it's important to keep those things in mind. If you want lower costs, you're almost always going to come with lower bit rates and lower range. Consider Bluetooth, for example, as maybe your ultimate low cost in many cases. Another thing to consider when you're selecting these is mobility. Do you need to maintain a call while you travel? Even if you're not on a voice call or a continuous connection like that, you may want it to continuously reselect quickly. In these kinds of cases, satellite and cellular are really targeted at that, and the cellular LPWANs are particularly well suited for that. But as you get to stationary use, then you can consider narrowband IoT. LoRaWAN is much better in that. Proprietary RF are going to be more well suited towards those things. And then, of course, you have to think about longevity. And nowadays, that means for cellular, you have to think about what am I going to do about 5G? how do I make sure that they're still here, a good connection, 5 years from now, 10 years from now, if you're the utility companies, for example. The established satellite vendors obviously have de-risked that some. Some of these startups, you're going to have to definitely consider what's their likelihood of being here in 10 years, what's the risk there. And the smaller private networks, again, you have the same kinds of things. So I think that 3G is obviously a good example of things going away. 4G will go away at some point. Carriers are already talking about dates for turning down or greatly reducing their 4G footprint. It's dates that most of you would care about, is my impression. Narrowband IoT, AT&T has already talked about deprecating that, and I don't really think that Verizon and T-Mobile have that many users that they're really very focused on ensuring good quality of service there. So consider the longevity of your application and the risks associated with your infrastructure. So diving a little bit into the low end, the IoT world in cellular. Maybe I'll start here in the middle and talk about Cat 1. So that's sort of the middle of the road standard for 4G. It provides kind of up to 5 or 10 megabits uplink or downlink. Typically, depending upon how much data you're using, you're required to use 2 antennas. And these modules can be pretty low cost, sort of maybe under $20. But it's widely available. It's going to be pretty much plug and play with the cellular network, and it will do almost anything you need it to do. Provide reasonable latency in the order of tens of milliseconds in good conditions. It's good for industrial applications, and you can do audio, video, even calls there. As you look to sort of save money and save battery, Cat 1 bis is the next option that's been rolled out there. Again, it's a 4G standard. It offers similar kinds of bandwidths, but only requires 1 antenna, so that decreases the complexity of your device, the cost, but it also decreases the range a little bit. It still has good global coverage and still provides high data rates for things like audio and video in particular. As we really get into what I think of as classic IoT applications, Cat M1 is a really strong contender there because it's optimized for range, optimized for power, optimized for size and cost. So you can lower your cost to under $10 with these kinds of modules. Your data rate is low and your latency can be high, depending upon the configuration. But that high latency means you can sleep for much longer periods of time, not just minutes, but even hours. So the networks are really designed to support all that. So it's a really good compromise for all kinds of different IoT applications, allowing you to optimize cost, battery, and size over the standard 4G application configurations like Cat 1. And it is part of the 5G standard. So we'll talk a little bit about that more on the next slide. Narrowband IoT is also an option, really very optimized for very low bandwidth, very low power, but support for that is a little spotty. But if you're highly driven by cost and size and it's available in your area, your carrier support it may be a very good solution. The bandwidth can be low enough that things like firmware over the air may get challenging. Not all implementations of narrowband were originally IP-based, so you may have some sort of inner working function that makes that complicated end to end. So we've generally shied away from that and focused on Cat M1 wherever we can. As we look at 5G, Narrowband IoT, Cat M1 are both part of that standard going forward, but the alternative to Cat 1 is eRedCap and RedCap at much higher bit rates than any of the things below, while still being highly optimized for just 1 antenna for lower cost and lower power. They probably won't be as low power as Cat M1 for a long time, but they're still options to consider if you need to do audio, video, or more serious kinds of mobility in real time. A few more details about these things. Again, highlighting Cat M1 is a great, IoT implementation. It has a very long range. This range is a figure of merit here for the higher the number of dB, the better the link budget. So you can see that it's considerably higher range. 6 dB will typically kind of double your range if you look at that, just to give you a quick rule of thumb. So great range, good mobility, good throughput, and included in 5G. And kind of going back to that original concept of efficient use of spectrum, both narrowband and Cat-M1, Cat-M2 allow you to deploy it in the guard bands where you just can't deploy a high bandwidth E-RedCap type signal, Cat1 type signal. You have to have certain spacing between these. You have to have certain spacing between these high bandwidth channels and the band edges. Those are called guard bands, and you can deploy something like Cat-M1 in those edges and use some more hertz than you could use otherwise. So it's very compelling for the carriers to consider this. It's not necessarily supported everywhere. So places like rural Asia, you may want to consider things like 2G fallback as important. But we have a pretty good summary here of some of those things. So as you're thinking about this, how do you also future-proof your module selection? So the cellular modules there's multiple carriers. They all have fairly robust and confusing and complex roadmaps, but we've always focused on considering a few key things. One, unless you have very high volume, first of all, you're going to be forced to use a module. So we really recommend that you look for a vendor that's got a longevity that you're comfortable with, has a footprint compatible modules across generations, 5G, 4 and 5G, to enable you to do future upgrades with minimum redesign. Often you may want to look for something where you can do both Cat1 for your high-speed applications and Cat-M1 maybe for your other applications, to give you a lot of design reuse and flexibility in your supply chain as well. Do those module vendors provide you a good family of configurations in the footprint you're using and the technology you're using so you can optimize it? Maybe you need one module that covers everything worldwide. That's a nice simple SKU. If your device travels globally, that can be an advantage, both from a supply chain and a user experience point of view. But if you're targeting cost, you may want to look at something that's only targeted at specific carriers or specific regions to really optimize that, or to remove specific features. If you don't need GPS or GNSS, then again, you can optimize your module cost, and you want to find a vendor who gives you a lot of good options. Not everybody knows about the complexity of carrier certifications. They don't necessarily make it easy, even with an approved module, to get your device on the air and certified. There's a lot of different wrinkles to this, but ideally you want to find a module vendor who can really support you with that and has robust carrier relationships. I think in general, all the main brands do, but it is definitely something you want to understand and discuss with them, because even if you're using an AT&T or Verizon approved module, there will be additional steps, whether that's FCC, PTCRB, or full certification. Depends upon your relationship with the carrier and how you're working with the MVNOs, the virtual operators who are reselling airtime on the carriers. As we mentioned, some places may not have all the technologies you want to use. So is 2G, 3G, 4G fallback necessary in the regions that you're going to be covered? And in some places, 2G may still be the best option. Here in the US, 2G, 3G are disabled, but again, there are many places where that's not true. And you may even want to consider non-terrestrial fallback to a satellite vendor, which is increasingly becoming an option with the same cellular module. And then one more thing to consider is 5G readiness. So there are modules now that are dual mode, 4G, 5G, that offer E-RedCap or a path to E-RedCap, as well as either Cat1 or Cat-M1. So you can connect today with the readily available, simplest to use technologies and have a clear roadmap to upgrade that in the future. So those are some of the key considerations as you're looking at your modules and your connectivity options. So just sort of to kind of wrap up and think about this, conclude here, look at your requirements. Where do you need to connect? Are you going to be able to connect reliably and consistency to the network that's there? And how do you maintain that connection over 5 years when new Wi-Fi access points are rolled out, when business models change for your LoRaWAN connections? How do you maintain those carrier relationships and optimize them? Once you know what your options are, how do you identify a solution that can send enough data with the appropriate latency and throughput? How do you provide, the power to this? Is it solar and energy harvested? You plugged into a wall that nobody's worried about? There's really important considerations here. do you need to do handoffs? Do you need instant connectivity, or are you just turning it on and waiting 5 minutes? That's okay. Then you need different mobility considerations. Of course, cost is always a concern, both of the data connectivity and the modules, and think about how much is it going to cost for you to do firmware upgrades, because you almost always will have to do that. So yes, you may only pay use less than a megabyte a month, pay a few dollars for your cellular connectivity, but if you have to push out a really large patch every month, how does that impact your data usage and your costs? And then of course the longevity, will it be there for the long term? So I think these are some of the key things to consider as you look at your IoT and cellular connectivity in particular. And I think I'm pretty much wrapped up here, David. So you want to go ahead and take it from here, or field any questions, feel free to jump in.
Just a reminder, if you guys have questions, go ahead and throw them in chat. I don't see any yet, but the information, Chris, that you just went over, I mean, we all know that all that stuff is great information to really, try to navigate everything that's out there. I thought Chris did an excellent job of giving you different examples, solutions, possible solutions for those examples in his presentation. Because as I said, again, those are all very important considerations. But when you think about Togo.io, the ecosystem itself, right? A simple way to put this, if you look at the swim lanes, like the first swim lane, right? You have your sensors, your devices. Then down below, you see device solutions, MQTT. There's satellite. There's lots of different connectivity options in swim lane 2, as Chris was mentioning. So you have a lot of choices out there, right? And then you have Togo.io, right? That's really going to do the processing of the data from the sensors and really display it. I like to think of Togo as much more than data visualization, and it is. I have people that are new to Togo. They ask for a demo, and they say, "Oh, you're just about visualization." And that's not true. I would say visualization is a very small part of Togo. It's an important part, but it's a small part, right? Because there's analytics, there's much more, there's reporting, right? There's forecasting, preventative maintenance. I can go on and on, but it's much more than just visualization, right? And so when you're looking at swim lane 3, right, you have your processing. What you're seeing up at the top where it says Togo.io, that's where you're developing your application on Togo, right? That is one of the sweet things about Togo, is that you can develop your own application from something very simple. And as you scale, Togo can scale with you because you are in the driver's seat, right? You are the developer. Of course, we have our professional services that you can use. Many customers don't have time or the resources to develop, or quite honestly, the knowledge, right? So they'll come to us. But when it comes down to it, you can build on Togo and never have to speak to our professional services. And thousands of customers do that, right? Like right now, we have over 500 devices, and I'll show you this. I'm going to do a live demo, just a quick one, but I'll show you some of this, right? But as I said, over 500 devices. But we also integrate, with SAP, Jira, a CRM, a payment system such as Stripe, lots of different options there. But as I said, when you see Togo.io, that's the admin. That's where you're developing, you're doing your integrations and things like that. Down at the bottom of swim lane 3, where you see run, that's Togo Run. And how I like to describe Togo Run, it's your user experience or your user interaction. Lots of options there as well. You have the freedom to develop your user experience at will based on your requirements, right? You can even put a video in the background of when they get to your page, right? Your Togo Run page, your end user experience. There's lots of things you can do there. So there's a lot of things going on in this slide, but if you think about it, it's really fairly simple, right? When we look at it from that aspect. And then if you think about it, integrating device data into Togo, how does the data get into Togo, right? I have another slide that's similar to this after this, but for this particular slide, you have your IoT devices and you have your connectivity type, right? You have your connector, which is your payload parser, and then you have the devices, and then your buckets is where your data lives on Togo. if we talk from an interoperability standpoint from Togo, right? Togo is very easy. If you need to replace your connectivity provider, it's a one-time handshake or authorization, and then you never have to do it again unless you change your connectivity provider. So you could switch very easily without jeopardizing your entire application, right? There's a few steps in there, but it's literally 1 or 2 steps and you're done, right? From a connectivity pipeline into Togo. Right. And then, as I said, the devices, lots of versatility there as well. But I like to think when I'm talking about interoperability with Togo, I'm really talking about how quickly can I change things? How can I be nimble and quick? Right. You can do that with Togo in many different ways, not just from a connectivity standpoint. Right. There's lots of things you can do. And as I said, since you are developing your own application on Togo, in some cases, as I said, we develop it. The nice thing about Togo is as your business requirements change, right? You're starting to scale or whatever it is, business requirements always change. We all know that, right? As they change, you can just develop right along with those changes and really have a seamless application. So very easy. Interoperability is number one, right? And then if you think of a logistics use case, but don't focus just on logistics, right? In this slide, we're saying here, okay, we have the people, we have our asset, we have the truck. And yes, through Togo, you can, location, temperature, humidity, but it's really more than that. You can even do driver behavior, which I have several customers that do this. Are they braking too hard? What's their speed? Right? Exactly. What is their location? Right? And so there's lots of things that go on with that. G-force, right? Impact, right? If you have a sensor that supports G-force, you'll be able to know when that shipment comes, the warehouse manager might look at that, look at his Togo application and say, okay, well, pallet number 2 had a G-force impact of whatever it is, whatever your threshold is. Don't even take that off the truck. I'm going to refuse that, right? And then you have your gateway, right? And then your Togo portal that we talked about in your mobile app. As I said, I work with a lot of customers actually here in New York, just north of me. I'm in Raleigh, that work with smart buildings. It could be 2 a.m. in the morning and I'm a property manager and I get a report that there's a leak in riser 1A downstairs on a particular building I manage. Through my mobile app, I can turn that valve off within seconds, and that's where preventative maintenance, it's one form of preventative maintenance, right? You're turning it off within seconds. But you can also do forecasting, right, for preventable maintenance. Lots of things to do there in the analytics world, right? And then, of course, integrate with other enterprise applications. I've been with Togo 5 years, and I can honestly tell you, I haven't seen anything that we haven't been able to integrate with, right? We've integrated with all sorts of different things, as I said, payment systems, CRMs, SAP, you name it. We've integrated with it most likely. So again, that's that back to interoperability. That's another form of that, right? I need to add something on my enterprise side to integrate with Togo. Very easy to do. So that makes interoperability very easy from that standpoint, right? I'm going to share my screen real quick, and I'll just spend a few minutes here to just show you a couple things. So when we're talking about devices, right? So here I'm in my admin, as I said, remember where I talked about Togo Run and the admin? Here I'm in my admin. And if I just go to devices, you're going to see this is where all my devices live. I'm going to show you the device list, but if I this one sent data 3 minutes ago, right? So here I can see that my data coming in. And keep in mind, there's some things here that you may not really care about. Like if I don't care about these zones, I could just put them in metadata where it's still searchable, but I don't need to visualize it, right? So there's some things you can do there to be more efficient on the Togo platform, right? If you ask for a demo, any one of our CSMs, including myself, would be glad to give you a one-on-one demo of the entire Togo IO platform and its capabilities. It's very powerful, and there's lots of stuff in Togo. I mean, we've been in business 10 years, so think about that. We've had time to really listen to our customers and develop the platform that they are looking for and they're comfortable with and they can scale with. And we've been very successful in that. And then you have your data chunks, right? You could export these, have a script to remove them if you don't need them after a certain amount of time. You have your emulator where you could test this out. There's samples here. Again, keep in mind, I'm in my device I called test 2. I can send data to that device. And so there's really lots of cool things in here, the inspector. But if we go back to the devices and let's say add a device, I can come here and you could search through over 500 devices. But let's say your device is not on our list, right? Then you can just right up here, and we have documentation on this, but again, glad to give anybody a demo, one-on-one demo. You can create your own connector because it's all in GitHub, right? There's some steps, obviously, you have to follow there, but you can create your own connector. So don't get discouraged if your device is not on the list. There's ways around. You can even create your own connector if you like, right? Connectivity, I should say. But if we look here, Cellular, which is one of Device Solutions, that's their product, right? You could just come in here. You would give it a device name, select your chunk period, how much you want to keep your data, give it a date range or a chunk retention. And in this case, IMEI, or maybe it's a EUI for a different type of device, right? And then you would just simply create your device, right? It's that simple. And then from there, you can really get into how you want to configure your dashboard and from a visualization standpoint, right? One thing I like to show here is this will kind of give you the concept. Here I have all my dashboards, right? I have all my dashboards, smart apartment. Here's all my dashboards. I've developed them. I've connected my devices to them, so on and so forth. And then from there, if I wanted to, right, you notice all the tabs up top. That's really nice to do. You have a lot of freedom here. But when you talk about Toggo Run, and obviously I'm not going to get into this too much. Again, ask for a demo. Be happy to do it. This is where you can make your configure your customer user experience. Everything from, put in a theme, company logo, change your colors. Again, put a video in the background. So I think you guys are getting the picture, right? You have the freedom on Toggo to do just about anything you want, not only from a development standpoint, but also from your end user experience, which we all know that, in my opinion, is one of the most important things, is how are your end users experiencing your application that you built on Toggo? There's other things in here, SSO, two-factor authentication, multi-language with a dictionary that you're free to use, your own custom email template, so on and so forth. So there's a lot to do on Toggo. Now, how do you get there, right? If you're new, right? What I recommend is go to our main site. And there's just a couple things I'm going to point out here. You can sign up for a free account. It's free. You have some limited resources, but with that said, you have a lot of freedom as well to develop, start developing, get a feel for it, or ask for a demo, take a tour of the website, so on and so forth. But in the resources, there's a couple things I like to point out here, is the Learning Center. This is free for anybody to take. It's a self-paced course. This is really going to help you get familiar with Toggo and how to start building on Toggo, whether it's something simple or complex. The 100 modules are more fundamentals, right? The 200 modules are a little more advanced, need to know a little bit of JavaScript. And I took these, and I'm not a developer, and I was fine. So, but I highly recommend, if you're interested on building on Toggo yourself, please take the Learning Center, as well as ask for a demo, right? Because that's going to help you, because you might have specific questions. I like to think of demos as, yes, I know what my job is because I work at Toggo. I'm the customer success manager, but we want to hear from you. What do you want to learn about Toggo, right? If we go back to resources, we also have dashboard templates. You can download these templates right into your profile. Again, this is a profile. right, have these different profiles. Think of them as sub accounts of your main account, but they have all the characteristics of your main profile, right? But here you can download these for free. These, sign up for an account. A starter account's only $49 a month. But you can download these and you already have pretty much a working dashboard. At least you have the template for one, and you own them. Once they're in your profile, you own them. So you can do pretty much whatever you want on there. One thing I would highly suggest as well is, let me go back to my slide real quick. Let me start this. Is I would, there's Device Solutions website. Contact them if you have any questions on that side. There's our website. But I would highly recommend to, follow both companies on LinkedIn, right? We're pretty active on there. Create your account on Tago, ask for a demo, as I said, right? So there's a lot of stuff. But as we said at the top of the webinar, Device Solutions and Tago.io have worked together very, very closely over 10 years, and we're in the same region. We see each other on site quite often, honestly. So just make sure you do your due diligence from our topics we talked about today. As I said, I think Chris did a very good job going through what's out there and really how to navigate that landscape, right? So I think that was very good. So with that, everybody, let me see if we have any questions. It looks like Chris already answered Jim.
Yeah, I just started answering Jim, but the more complicated it is in terms of your device characteristics, the more bands and bits and modes, the more likely it is going to be hard. And even if it is FCC approved, there's at least some testing to go through. No matter what, your digital device will require FCC 15B for unintentional emissions, so you need to do that no matter what. And if you're using an approved module, there's still restrictions and kind of rules. You should double check that you're within the boundaries, even if you don't need full certification. And of course, the carrier story is always evolving, so it's best to kind of talk to your carrier and figure out what the options are. Push them pretty hard to make sure that that's the best option for you, because there's lots of things to consider. Going directly with the major 3 carriers, working with an MVNO, things like global roaming, which is a little bit of a risk. All those kinds of things are something you need to talk over and investigate more.
Very good information. All right, I think that's it for our webinar today. Thank you, everybody, for joining. Chris, I appreciate you so much for doing this webinar with us. It was very good. I'm already getting feedback in my inbox that I'm kind of monitoring out of this corner of my eye. So some good stuff. We will see everybody next time. And again, thank you, Chris.
All right. Thank you, everybody. Really appreciate you making the time.
All right. Bye-bye.